This video explores operations management, focusing on just-in-time and lean production systems. The outline covers JIT and lean production, the profile of green gear cycling, suppliers, and JIT layout, which includes distance reduction, increased flexibility, employee impact, and inventory reduction. We will continue the outline with inventory management, scheduling, quality, employee empowerment, lean production concepts, and JIT application in services. By the end of this video, you will be able to identify or define types of waste, variability, and Kanban. You will also be able to describe the JIT philosophy, pull and push systems, the goals of JIT partnerships, and lean production. A key quote defines waste as anything other than the minimum amount of equipment, materials, parts, space, and workers' time that are absolutely essential to add value to the product. Green Gear Cycling designs and manufactures high-performance travel bicycles. Their strategy involves mass customization, low inventory, work cells, and a major focus on JIT, supply chain management, and quality. This diagram illustrates the flow from supplier distribution and in-transit inventories to production inventories and finally to customer distribution and warehouse inventories, showcasing the entire system. Just-in-time, or JIT, is a management philosophy of continuous problem-solving. Supplies and components are pulled through the system to arrive exactly where and when they are needed. Lean production is focused on supplying customers with exactly what they want, when they want it, without waste, through continuous improvement efforts. JIT attacks waste by eliminating anything that doesn't add value from the customer's perspective. It exposes problems caused by variability and achieves streamlined production by reducing inventory. The types of waste include overproduction, waiting, transportation, inefficient processing, inventory, unnecessary motion, and product defects. JIT implementation led to significant waste reductions at Hewlett-Packard, including 82% in work-in-process inventory and 50% in raw material inventory and lead time. In a push system, material is pushed downstream regardless of resource availability. Conversely, a pull system pulls material to a workstation only as it is needed. JIT contributes to competitive advantage through suppliers and layout. This includes fewer vendors, supportive relationships, quality on-time deliveries, and flexible work cell layouts with minimal inventory space. In inventory, JIT uses small lot sizes, low setup times, and specialized bins. Scheduling utilizes zero deviation from schedules, level schedules, informed suppliers, and Kanban techniques. JIT's contribution continues with preventive maintenance, featuring scheduled and daily routines and operator involvement. Quality production focuses on statistical process control, quality by suppliers, and quality within the firm. Further contributions include employee empowerment through cross-trained staff and few job classifications for flexibility, supported by adequate training. Commitment involves strong support from management, employees, and suppliers. The results of JIT include reductions in queue and delay, speedier throughput, freed assets, and winning orders. This is achieved through quality improvement, cost reduction, variability reduction, and rework reduction, all minimizing waste. All these factors yield a faster response to the customer at a lower cost and higher quality, ultimately resulting in a competitive advantage. The JIT success factors shown in the diagram include employee empowerment, quality, preventative maintenance, suppliers, layout, inventory, and scheduling, all centered around JIT. JIT partnerships with suppliers are characterized by having few, nearby suppliers, repeat business, and supporting competitive pricing. Buyers resist vertical integration, and suppliers are encouraged to extend JIT practices to their own tiers.
Regarding quantities, JIT partnerships focus on a steady output rate, frequent small lot deliveries, long-term contracts, minimal paperwork, and fixed delivery quantities with no overage or underage.
In terms of quality, Minimal product specifications are imposed, and buyers help suppliers meet quality requirements. There is a close relationship between quality assurance teams, and suppliers use process control charts instead of lot sampling. JIT shipping practices involve scheduling inbound freight, gaining control through company-owned or contract shipping, and using the Advanced Shipping Notice, or ASN. The overall goals of JIT partnerships are the elimination of unnecessary activities, in-plant inventory, in-transit inventory, and poor suppliers. Suppliers may have concerns about diversification, poor customer scheduling, frequent engineering changes, quality assurance, small lot sizes, and physical proximity to the customer. The streamlined production model contrasts the traditional flow, where inventory in stagnant ponds buffers the water flow, with the JIT flow, where reduced inventory reveals problems. The JIT objective for layout is to reduce the movement of people and material, as movement is considered waste. This requires work cells, movable machines, short distances, little space for inventory, and direct delivery to work areas. A work cell layout, shown on the right, contrasts with the traditional process layout, demonstrating a more streamlined flow for production. This illustration shows how a high inventory level hides problems like scrap, setup time, late deliveries, quality issues, and process downtime, much like water in a lake hides rocks.
Lowering the inventory water level reduces waste and reveals underlying problems such as scrap, unreliable vendors, and capacity imbalances. The goal is to reduce inventory to uncover these issues. When inventory is reduced further, the problems become more exposed, encouraging their resolution. Solving these issues is critical for the success of just-in-time. Ultimately, the inventory level is kept very low. This exposes all problems so they can be solved, leading to a much more robust and efficient system. Reducing lot sizes increases the number of lots to process a customer order. For an order of 10, a lot size of 5 results in 2 lots. Reducing the lot size to 2 results in 5 lots. Reducing lot sizes is essential for JIT, but it increases the number of setups. This is only economically feasible if setup costs are reduced to lower the total cost and the optimal lot size. Setup time reduction is achieved through several steps, dramatically decreasing initial setup time. This includes separating internal and external setup, improving material handling, standardizing tooling, and using a one-touch system. Small lots increase flexibility to meet customer demands. The JIT small lot approach allows for a mixed production of products A, B, and C in the same time frame as the large lot approach, but with greater variety. Kanban, the Japanese word for card, authorizes production from downstream operations, pulling material through the plant. It can be a card, flag, or verbal signal, often used with fixed-size containers. This diagram illustrates an outbound stock point with a warning signal marker. This visual management tool helps control inventory levels and signal when production is needed. Kanban signals effectively pull material through the production process, ensuring that upstream operations only produce when authorized by downstream demand. JIT principles are also applied in services, utilizing techniques from manufacturing. This includes optimizing aspects like suppliers, layouts, inventory, and scheduling for improved efficiency. Lean producers use JIT to eliminate inventory, build systems for perfect parts, reduce space, develop close supplier relationships, and eliminate all but value-added activities. They also focus on developing a flexible and skilled workforce.